Earth is the water planet. Although 40% of Earth's population lives within or near coastal regions, the ocean impacts people everywhere. Most of Earth's water is stored in the ocean, a driving force for weather and climate. The Earth's surface is warmed unevenly by the sun. Heat, a form of energy, helps drive ocean and atmospheric circulation. The ocean absorbs and stores more heat than the atmosphere. Both the atmosphere and ocean move heat. The atmosphere does this quickly, the ocean slowly. At the ocean's surface, winds drive currents. Multiple forces keep the global ocean conveyor belt, or thermohaline circulation, in perpetual motion. Below the surface, deeper currents are driven by differences in density. Mixing and upwelling in the ocean, transporting nutrient-rich waters to the ocean's surface. Nutrients sustain biological productivity in the ocean. Extreme variations in sea surface height and sea surface temperature affect ocean and atmospheric circulation. El Niño and La Niña occur when changing wind patterns displace warm and cool water in the equatorial Pacific. Both have global impacts. During either of these events, the replacement of cold water by warm water leads to air temperature swings and changes in humidity. This alters weather patterns by steering storms and rainfall to new locations. Shifts in rainfall affect plant growth and areas impacted by drought. When heat is exchanged between the ocean surface to the atmosphere, it influences climate. For example, heat and moisture carried by the Gulf Stream northward bring warmer temperatures and a moderate climate to Europe. An eddy is a circular moving body of water that spins off a main current. Eddies play a major role transporting heat and nutrients. Thunderstorms are a frequent occurrence in the tropics. Some of these may become organized into large rotating systems with strong winds growing into tropical storms or hurricanes. Tropical ocean basins like the Caribbean and the Gulf of Mexico retain substantial heat, making these regions favorable for rapid storm intensification.
The ocean is a very complex system, and it is never at rest. Ocean currents travel around the planet and go through a lot of ups and a lot of downs along their journey. Because ocean waters are so good at holding heat, and because the currents are constantly circulating massive amounts of water, oceans are major players in any discussion on global climate. In this lesson, you will learn about the patterns ocean currents take and how they affect climate. Ocean currents travel at both the surface of the ocean as well as deep within the ocean basin. Currents are influenced by factors such as wind, the rotation of the Earth, differences in the water's salt content, temperature, and density, and even the shape of the ocean floor. Surface ocean currents are strongly influenced by the wind. Prevailing winds, which are winds that blow predominantly from a particular direction, flow across the ocean surface, pushing the water in large circular ocean currents, called ocean gyres. It might help you to recall this term if you remember that the word gyre is Latin for circle, which is the pattern these surface currents take. Or maybe you played with a gyroscope when you were a kid, which was a wheel-shaped science toy that could spin on its base in all kinds of crazy ways without falling off. Ocean gyres are present in every ocean and move water from the poles to the equator and back again. The water warms at the equator and cools at the poles. Because ocean water temperatures can transfer to the air, the cold and warm waters circulated by the gyres influence the climate of nearby land masses. Gyre circulation is influenced by the Coriolis effect, which is a phenomenon created by the rotation of the Earth that causes rotation in a clockwise direction in the northern hemisphere and counterclockwise in the southern hemisphere. Along wind-blown coastlines, we may see areas of upwelling. Upwelling is the rising of cold, nutrient-rich water to the surface. As winds blow along the coast, they move the relatively warm surface water. This allows colder and nutrient-rich waters from the ocean floor to rise up and take its place. The ocean's bottom waters are rich in nutrients because sea plants and creatures decay and release their nutrients onto the ocean floor. As these waters rise up, they feed marine organisms in the area, so upwelling areas are usually rich in marine life. Deep ocean currents are strongly driven by the density of the ocean waters, and the density of ocean water is mainly dependent on the water's temperature and salinity, or salt content. Basically, the colder and saltier the ocean water is, the denser it will be, making it sink toward the ocean floor. Thermohaline circulation is the largest ocean circulation pattern and is directly related to temperature and salinity. In fact, if you break the word thermohaline down, you see that the prefix thermo refers to temperature or heat, and the suffix haline refers to salinity. So the thermohaline circulation pattern is driven by changes in water temperature and salt content. The thermohaline circulation is sometimes referred to as the global ocean conveyor belt because it moves water on a path through the world's oceans as if it were on a giant conveyor belt that travels the entire globe. As you can imagine, this current moves a massive amount of water and distributes heat along its way, which in turn influences the global climate. Now, we mentioned that the thermohaline circulation is dependent on the temperature and salinity of the water, and we know that cold, salty water is more dense or heavier and therefore sinks. With this knowledge, we can understand how the water flows in this circulation pattern. The pattern begins in the frigid northern waters near Iceland, where the ocean water is cold and salty. This cold, salty water is dense and starts to drive the current. The current moves on a path southward across the equator and down the coast of South America. Along its travels, the current builds and picks up momentum, and by the time it nears Antarctica, it is massive. The current moves along the bottom of the world and splits, with one branch entering the Indian Ocean and the other entering the Pacific Ocean. The branches of circulating water warm in these oceans and then rejoin as they turn west and get drawn back up to the polar regions where they began their journey. And quite a journey it is. If you were an individual water molecule traveling the thermohaline circulation, it would take you nearly 1,000 years to go from start to finish. This is a long time, but the thing to remember is that there is a continual cycle of heat and energy that affects everything from the climate around the world to your local weather forecast.
a driving force for weather and climate. The ocean is essential to life on Earth. It is the primary storehouse of Earth's water. Without the ocean, our planet would be uninhabitable. NASA satellites and their unique view from space are helping to unveil the vast and largely unexplored ocean.
Tell me pretty lies, look me in the face, tell me that you love me.